So yes, my name is Dylan Beattie, and they've invited me up here tonight to talk to you about something I call the secret to happy code. So, a little bit about me first. This is me. I have been building websites since 1992, so basically I am an ancient internet historian. I'm a CTO at a company in London called Skills Matter, who some of you may have heard of. We organize a whole bunch of training courses, some of the big UK conferences throughout the year. I've been working with them for about 3-4 months now. I'm a Microsoft MVP for Visual Studio and developer tools, which is pretty cool. Thank you, Microsoft. Mainly because I organize the London.NET user group. So if any of you is ever down in London and wants to come along and speak, or just come along, see the venue, meet some of the gang and hang out, you would be very, very welcome. Pardon me. All my contact information is on here. Anything in the talk tonight that you want to chat about, anything that you want to, questions, ideas, anything you've seen that you think kind of works with these themes and things, please get in touch. Always happy to chat. Really, happy to talk on Twitter, email, whatever works for you. I am also, since I'm at the Sheffield.NET group, going to just plug ProgNet 2018, which is Skills Matter's big .NET conference, which is in its 10th year now, I believe. It's in September. It's a little bit different to most conferences. We have a day of, standard sort of 1-hour talks, but then we have 2 days where all of the talks are 3-hour workshops. And you bring your laptop, we set the rooms up classroom style. The idea is that you actually go home with some code that you wrote yourself running on your own machine. So you don't just go home with all of, really, really interesting ideas and things to go away and Google. You actually go home with something that you've implemented yourself. And then a couple of weeks later, when the same problem comes up at work, you can dig out the code you wrote and go in and see how you did it, see what you actually did there. It's in September. We have an early bird ticket discount, which actually runs until tomorrow. So go into work tomorrow morning and say to your boss, hey, I need to go to ProgNet because if we don't book it today, the prices are going to go up. So it's 850 quid if you book it by the 6th of June. And it would be awesome to see some of you there. It is a really, really cool and fun event and something I'm happy to be involved with for a long while. Right. Plug over. Let's talk about code. So before I joined Skills Matter, I've spent much of the last sort of 15 years working for a company called Spotlight who work in show business. We're a directory of actors, actresses, and professional job information services for films and television and stuff. And whenever we would go and speak to any agency or consultancy or anything, they would prepare a spiel, a presentation for us, and they would always use the same clip art on the first page, which is this, which is the Greek theater masks of comedy and tragedy, happiness and sadness. And that kind of leads into the theme of the stuff I'm talking about tonight, because in the years and years and years that I've been building software, what I've noticed is there are days when we love our jobs. There are days when you go into work and you enjoy what you are doing. You are solving problems, you're having a great time doing it, you're really productive, you ship really, really good stuff. And those days, I've noticed, tend to correlate with high quality output. And I've also noticed that there are projects which should go very, very well. They're, well funded, it's an interesting problem, it's a good team. And after a couple of weeks, people just start kind of looking grumpy. They get in and they're like, I'm still stuck with this thing, I can't get this thing to work, the build pipeline is still giving us headaches. And those things, I've noticed, seldom produce usable software. A lot of those projects end up getting cancelled. And the ones that don't end up getting shipped to production by just, banging away on them until finally something launches. And I would rather be in the first camp. I'd rather be working on, happy teams who enjoy what they do and who produce good stuff. And so what I'm going to be looking at tonight is a whole bunch of different ideas from different areas of computer science and psychology and education and research about how we can try and make sure that our teams and the people we work with are in that first camp. So one of the ideas I'm going to talk about is something called discoverability. Now, basically, discoverability, when you're referring to a system, if you say it's discoverable, what it means is you can explore it for yourself. It is a system that encourages experimentation. You feel like you can go in and you can play with it. You can learn for yourself how this thing works. You can make your own observations. You can come up with theories about how it works, and you can try those theories out. And this ties very closely into another idea I'm going to talk about, which is something called dopamine. Now, dopamine is it's a neurotransmitter. It's a chemical that gets released in the human brain Dopamine is, it's the addiction chemical. It's the thing that gets people hooked on gambling or hooked on roller coasters, or, it's the thing that keeps you going back and looking for another thrill. But it's also the thing that gets released when you solve this latest level on Super Mario, or you get a clear the pit in Tetris, or when you get that little problem you've been wrestling with in your code and you manage to get it solved. And if you've ever had one of those nights where it's 10 o'clock at night and you think, oh, I'm going to wrap this up and go to bed soon, and then you get something to work, and then you get something else to work, and you get something else to work, and you get into this little feedback loop until suddenly, it's 3 o'clock in the morning and you have no idea what happened to the last 5 hours, but you've just been going round and round and round getting things working. That's dopamine. Every time you solve one of those little problems, you get this little rush of positive reinforcement in your brain. And the interesting thing about dopamine is that it actually makes us better at learning things. If you learn a system by solving puzzles and problems and working it out for yourself, every time you kind of hit one of those little tiny milestones, you get this dopamine rush and your brain just becomes more receptive to the thing you've just learned. You retain it more easily, you'll be able to use that information more quickly. It's a radical sort of contrast to learning something by rote, reading the manual or going through pages and pages of documentation. It's just a much faster way for people to get up and running and productive on systems. So we talked about learning. I just want to talk a little bit about something called learning curves. Now we have this, this expression in English. We talk about, something had a really steep learning curve. And generally, if someone says a steep learning curve, they're referring to something being difficult. It tends to be used in quite a negative way. So I've got 2 learning curves here. I've got this one here, which is the blue one, which is steep, and I got this one here, which is a red one, which is shallow. And I just want to, curious, by show of hands, how many people think that the blue learning curve here is better? Yeah, we got a couple. How many think the red is better? How many think that's a dumb question? It is a dumb question. Both of these learning curves are kind of fine, because in both cases, the more time you invest in something, the more experience you get, the more expertise you get with that system. The more time you put in, the more you get rewarded, and it is basically a positive correlation. Now, in the one instance, the steep learning curve here, this is that colleague you had on your team who comes in one Monday and they're like, oh yeah, I learned Haskell in the weekend. And you're like, you did what? And they're like, yeah, it wasn't that hard, And you're like, you learned Haskell in a weekend? And then this one is the person who we've all worked with who's been using Microsoft Word for like upwards of 10 years, and they still don't know how to do a page break, and they still indent things by doing lots of spaces. One of these, somebody invests hard in a system, they learn it very quickly. The other one, somebody doesn't really invest anything and they don't learn very much about it. They're both all right. The thing that we want to look out for is learning curves that look like this. Because when a learning curve looks like this, we get this thing here, which is a localized peak. Now, in software, we can't really get away from abstractions. When someone says, I want to learn to code, you don't go, right, we're going to start with arithmetic logic units and relays, and we'll build it up from there until you understand microprocessors, and then we'll talk about registers, and maybe in 5 or 10 years, you'll be ready to talk about ASCII. We go, look, console.writeline, hello world. See, it works. It's an abstraction. And all of the systems we build are built on these layers of abstractions. But when you create an abstraction over something, pay very close attention to the mental model people are going to end up with. By show of hands, who here has worked with ASP.NET web forms? Yeah, good. I like it when you get a lot of show of hands, because it means people relate to Microsoft shipped this amazing framework that made the web look like Visual Basic. You could take a blank web page and you could drag a button onto it, and then you could double-click that button and write some code. And you could put inputs and drop-downs, and they maintained their state, and you could build an interactive web application, just like we used to build, Visual C++ and Visual Basic apps. People who invested in this Visual Basic ecosystem, they got really, really good at dragging and dropping controls and writing on-item data bound and on-click handlers and everything. And then one day, a client would come to them, or their boss would go to them and say, we need to build a streaming video server with buffered playback so clients can stop playing a video and then restart it again. And you'd go and look in the toolbox in Visual Studio, and there's no streaming video restart player control in there. And so they'd sort of, yeah, I'm still all right, is that? And you'd start thinking, how do I do streaming video in ASP.NET web forms? And you'd realize that the thing you had learned how to do was not actually HTTP and HTML. You hadn't learned very much at all about how the web worked. You'd learned how ASP.NET web forms worked. And in order to build something like a progressive video server, you needed to get rid of everything you'd learned, and you needed to start again. And that's a really, really demoralizing feeling. Somebody feels like you've pulled a fast one on them. You've invested all this time in learning this abstraction, and then suddenly you realize you've wasted your time. You've got to go back to the beginning. You don't know what you're doing. You can't turn around to your boss or your customer and say, yeah, no problem, we can do that. And so that's the week when you go home really, really, grumpy and fed up at the end of it all. You learn web forms, and you kind of invest all this time in learning this programming model that you then suddenly realize was not actually an accurate reflection of the things that it simplifies are things it shouldn't have simplified. It was teaching you the wrong thing. It was teaching you the wrong kind of abstraction. So when you're creating, documentation or APIs or any kind of abstraction over a system, be very wary of anything that is going to mislead people who are taking the time to familiarize themselves with it. Because when they discover that it's wrong, they're going to be upset. The other thing you need to watch out for in learning curves is the owl effect. You get step-by-step instructions for how to draw an owl, and they say it's easy. Step 1 is you draw an oval for the head, and then step 2 is you draw an oval for the body. And anyone know what step 3 is? Draw the rest of the owl. And you're like, okay, I don't understand what happened there between step 2 and step 3. These are not step-by-step instructions. What you've done is to create a learning curve that looks like this. But because no one can work out how to get from here to here, what you've actually done is you've created kind of the beginner's thing and the advanced thing, and you haven't given any support to people who are at the intermediate stage. The best example I found of this is monads. There are people who live over here, and they're fine with recursion and encodings and all kinds of things. And then there's people over here who go, well, there's this category of endofunctors, and these are just monoids that are in it. And you're like, I don't understand. You haven't given me any way of getting from this stage to this stage. Now, one of the things that first started me kind of thinking about the ideas that went into this talk was about 10 years ago, when alt.NET was kind of all the rage, and the whole .NET community and ecosystem was starting to explore the idea of using open source tools and frameworks and things. And I was playing with something called Castle Windsor. And I downloaded Windsor, and I installed it, and I thought I'd done everything right, and I pressed F5 to run it. And I got the yellow screen of death, and I thought, oh no, it didn't work. And then I thought, this is interesting. Because what this error message actually says, it's not the usual null reference exception. It says, hey, looks like you forgot to register the HTTP module. Now, one, I really like the way that's written. It's not saying error or bad or invalid or missing or null. It's saying, hey, it looks like you forgot. Yeah, we're going to pretend that you know what you're doing. It looks like you forgot. And then it says to fix this, add, and then it gives you this little snippet of XML right there inside the exception that gets thrown. And you go, all right, copy, open web.config, paste it in, and you press refresh, and it works. And 3 things happen. 1, you get the little dopamine rush. I fixed it. I solved the problem. I didn't have to read the manual. 2, you get Castle Windsor up and running, and then you can start trying to do the thing that you were trying to do that day. And 3 is you think, I like Castle Windsor. I like the people who wrote it. I now have a positive kind of impression that the people who wrote this software care about me, and this is a tool that if I start using it is probably going to help me build better systems. Because there's this kind of common conception in a lot of software product development that user experience is, we have a UX team who do that, or a UX person who does that. And that user experience is somebody else's problem, and users are the customers, the end users, and everyone else is just techies. But actually that's not true, because at every single level of any modern software project, you are building things that somebody else is going to use. You create a relational database schema, somebody is going to have to get data out of it. If you create a class library, somebody is going to use that. If you create an API, somebody is going to use that. If you create a component library or a set of front-end widgets, somebody is going to use it. All of us are creating user experiences almost all the time in the way we design our systems. And so we can make a massive difference by just learning a little bit about how to create better user experiences. So let's walk through a scenario. You've started a new job, new company, new team, you're really excited about it. You go in on a Monday morning and you get the, hey, welcome to Initech or whatever. Bathrooms are over there, there's the coffee machine, introduce you to everyone, and then they sit you down at your desk and they say, right, step 1, let's get the website up and running on your local machine. So you go, okay, how hard can this be? I'm a serious software developer, I can do this. And you log into GitHub with some credentials that someone gave you, and you start poking through the repos. You're like, okay, website, that looks promising. And you clone the repo called website, and you look at it, and it's empty. You think, okay. And you go back and you look through GitHub, you see, website 2017, maybe that's it. And you clone that one, and there's nothing in there. And you go in and you see, website 2, and you think, and after about 10, 15 minutes of this, you're not getting anywhere. So you turn to your new colleague who's sat next to you, and you go, hey, I'm really sorry. And they take their headphones off, and they're like, hi, what's up? You say, I can't find the code for the website. And they say, oh, yeah, it's in a repo called sales. And you're like, okay. And they say, yeah, the sales team hired the developers who built the original one, and that was the repo they were using. Okay, fair enough, whatever. So you check out the sales repo, and you press Shift-Control-B to build a solution, and it fails. It cannot find mycompany.finance.dll. And so you think, well, I could Google it, but it's mycompany.finance. It's probably not on Google. So you turn to your new colleague, and they take their headphones off again. You say, I can't find my company finance DLL. It's not in the repo. And they go, oh, yeah, that's the interface to the accounts program. Tell you what, I'll share my C drive with you, and you can just copy all the DLLs you need. At the point where someone wrote that message, they knew what was happening. They knew the problem that was going on, and they decided not to share that information. Now, I think that is a really, really negative thing to do. The operation could not be completed, unspecified error. When you throw these kinds of error messages, you're just going to give someone a really, really bad day, because that's a brick wall. There's nothing, you can't Google that error message. There's no clues in it. There's nothing you can work with. It's just a dead end. So let's run the same scenario, but you've quit that job because it sucked, and you've gone to work for a different one. And you get in, and same deal. Hey, welcome to your new job. There's the coffee machine. There's the bathrooms. Here's your desk. Meet your new colleague and their headphones, and let's get the website up and running locally. And as you're sitting down, your new colleague takes their headphones off, and they go, hey, by the way, the website project code name is Applejack. And you're like, okay, thanks. And you go onto GitHub, and there, A for Applejack. You clone the repo. There's the website. And you press Shift-Control-B, and you see restoring NuGet packages. And then you see, restoring from nuget.mycompany.org, and you think, that's pretty cool. Somebody here actually built a NuGet package server for all of their DLLs and things. And you see mycompany.finance.dll, you think that's pretty neat. And then you press go, and up comes a screen, and it says, hey, well done, the website's running. You're going to need a database. Go and have a look in the SQL folder of the repo you just cloned, and you'll find all the data creation scripts. You run those, come back, try it again. 3 things happen. 1, poof, dopamine, you've solved the problem. 2, you've got the thing up and running. The project is running. You have this wonderful positive impression of your new company you're working for. And after a couple of hours, your colleague takes their headphones off, and they say, hey, you want to come and grab a cup of coffee? And as you're walking out, you say, yeah, I got everything running. Why is it called Applejack? And they say, we just name all our projects after ponies. And you're like, what? And they say, yeah, we just realized it would be much, much easier if all of the kind of natural bounded contexts in our software, we just gave them all code names. So, the website is called Applejack, and the finance system is called Bumblebee, and this is called Cherry Brandy, and this is called something else. And the names are stupid, but, the point here, one of the hardest things in coming up with names is thinking the names have to be, cool and marketable and meaningful. Just pick a list of dumb names with lots of names on it. And next time you need a name for something, grab one. Because once you make that leap of saying the website is called Applejack, you'll realize that's it. Applejack is the repository code name in GitHub. Applejack is what you search for on the wiki. Applejack is where the emails come from. Applejack is what you put in the log files and on the dashboards. And just that act of trying to identify the bits of your digital estate which could meaningfully have a name is a really big step forward to making it easier to understand the way distributed systems are built, the way they run, the way they communicate, the way they're managed. Okay. Time for a little history lesson. When I first started learning to code, it was on one of these. This is a 286 PC, 12 megahertz, 1 megabyte of RAM. I'd been pestering my parents for weeks to buy me this thing because I was like, I need a computer because I can't be a computer hacker if I don't have a computer. And they bring it home, and I unpack it, and I switch it on, and it says A. And I think, all right, brilliant. Hello. And it says bad command or file name. And I go, okay, menu, and it says bad command or file name. And I say help, and it says bad command or file name. And I'm like, I don't mean to be bad. I want to do computer stuff. Help. And so, again, brick wall, this little A prompt. The only fun thing you could actually do with MS-DOS was you could do this. You could do, if you're happy and you know it, syntax error. And it would say syntax error. But other than that, MS-DOS was not a very happy computing environment. You had to read the manual. And the manual was badly written, and it was about 2 inches thick, and it was, you know, really, really kind of, literally you switch the machine on and it gives you a brick wall. And it's like, unless you know what you're doing, you are going no further than A. That's it, you know, dead end, out of the box. The other computer that you could get at the time was the Apple Macintosh. And when you switch that on, you got a little smiling face picture of the computer that you just put on your desk, and then you got this thing saying, "Welcome to Macintosh." And it would kind of clunk and spin for a couple of seconds, and when it loaded, instead of A, you got this. You got a GUI desktop. And it took you about 2 minutes to work out that if you move the little mouse thing, this thing would move around the screen, and then you're like, okay, this is cool. There's things here I can click on. I can explore this system. It's taken the kind of underlying ideas, the metaphors and the models that the operating system used, and it's put them on the screen where you can see them. Now, this is an incredibly powerful and successful metaphor, but what an awful lot of, you know, organizations and products have done is they've taken this idea and they've gone, okay, put things on screen, that's how we make it user-friendly, got it. And they ship this. Now, this is Visual Studio with every single option turned on at the same time. And this is as bad as DOS, you know, because you have no idea at all. There is nothing on here which tells you what's important and what's not. There's nothing here that kind of tells you where to get started. There's nothing here that offers you any kind of learning curve other than just randomly clicking on things and hoping that you understand. You know, this thing here, Start, you're going to click that 100 times a day for the rest of your career. This is the UML Model Explorer. You are never going to use that, ever, for anything, you know. But when you just put everything up on screen at once, you just overwhelm people with choice overload. They have this massive information. They have no idea how to work with it. What we want to do is create systems that they gently encourage this kind of exploration, and then they reward it with feedback. So, yeah, we just had a look at the way Microsoft Edge has this reactive user interface that takes a lot of the complexity out of the way of kind of the casual everyday users, but it picks up on the cues that you as a developer can give it, and at the exact point where you kind of go, I want to enable developer tools, it pops up and it says, all right, we're going to make this easier for you next time because we appreciate what it is you're trying to do here. You can use very similar ideas in backend systems. So we've looked at a couple of examples that are kind of very, very user-centric things. Now, I'm sure that this being a .NET user group, you've all come across the idea of IntelliSense, what they call intelligent code completion. Object-oriented language with an ID, you type console dot and it just gives you this list of all the things. And you know, on really, really bad days, you can actually write entire programs just by going console dot, I wonder if there's anything here that might be able to help, you know. And this is a really, really nice way of exposing kind of UI behavior and stuff. But something, you know, everyone's familiar with this. You've all seen this before. I've seen this before. This is not what I came here to tell you about. What I think is interesting is when you think, have you ever used this in your own class libraries to make it easier for the people who are going to be working with them? Now, I've been doing, you know, .NET development since .NET or Microsoft .NET Beta 1, so probably coming up on 15 years now. I still cannot write a connection string from memory. I go using var SQL equals new SQL connection, and the documentation pops up and it says string connection string. And I cannot remember the syntax. I still have no idea how to write one of those from memory. It just won't stick. So what I did is I wrote a little thing called SQL.connect, which does exactly the same thing, but what I did is I pasted the missing documentation into the prompt that you get from SQL.connect. And so at the exact point when normally I'd get stuck and I'd have to, you know, go and look on connectionstrings.com or something, this little thing pops up on the screen and it goes, this is the bit you can never remember. We'll do this between us. I'll remind you and you fill in the passwords and stuff. And the code which makes that happen is really, really simple. If you look at the definition of SQL.connect, all it is it's a static method that literally does equals new SQL connection string. But the clever part is this XML parameter prompt here. And all I've done is to just paste in the stuff I can never remember inside this param definition. And you can use this same technique. If you're building class libraries, utilities, helper classes, anything that other people on your team are going to use, you know, this can even be a great way of like slowly introducing people to business process and business logic. If you've got things like, you know, some kind of shipping system which has different invoicing rules, why not put the documentation for those invoicing rules in the code itself? So when someone goes to write a line of code, you know, order.dispatch to open, and they're like, this enum, I'm not sure what it means. Well, no, you don't need to worry about what it means. The documentation is right there on the screen for the 3 or 4 seconds it takes you to make a decision, and then it's gone. Now, all of these ideas are pretty good if you have a good idea of what your user is trying to achieve. But what I want to talk about now is an idea called signposting. Now, signposting is about signifying the different journeys and states and operations that are available at a particular point in the process. Now, one of the really useful examples of this is when you're building APIs, you can use a pattern. You've probably all heard of REST and or hypermedia, and you've certainly all browsed the World Wide Web. You can use hypermedia architectural patterns in your backend APIs and a little bit of JavaScript to actually make APIs that you can explore like a sandbox. So this is a real system that my team at Spotlight shipped last year. We built this API over some of our data systems, and we built this little JavaScript tool initially to help us test it. And then we thought, well, this is actually really useful. Why don't we ship the tool? So we polished it up a little bit. And what this basically gave us, so first of all, it's got authentication built in. It's got bookmarks built in. You can switch it between the live system and the sandbox. So if you want to try something out that might be destructive, you can do it. And then what we're doing here is we're making calls to an API in the backend that returns HAL JSON. So HAL is a hypermedia format that works with JSON. And then we're decorating that in this browser tool to make the whole thing interactive and navigable and clickable. And we can actually go through, so as well as just clicking from one resource to an associated resource and doing these kind of read-only, these GET requests, we've even got some hypermedia controls in here. So we've got a performer here who's 1.8 meters high. And within the browser, we can submit the JavaScript operation that's going to update it and modify that part of that data record. And this thing, it started out as a kind of nice idea. We shipped it. Actually, it's proved really, really good. Because the clients who are using it, one, they love it when they say, do you have an API? And we say, yeah, put your username and password in here and see what you can do. And this makes sense to them. They recognize the names of their clients. They recognize the information that's being displayed because that relates to the business that they work in. And it's proved really useful when they have a problem with, because we've got clients building stuff in Ruby and Node.js and PHP and all kinds of languages. So when they send us a chunk of code that doesn't work, we're like, well, we're not going to set up a Node.js environment just to try and help you with your problem. Please go and try it in the Explorer. And if you can reproduce it there, send us what you did there. And a lot of the time, they'll go, oh, no, it's OK. It worked in the Explorer, and now I see the problem. So it gives them this kind of feedback loop they can work for themselves, which, again, gets this thing of, I didn't have to ask somebody for help. I managed to figure this out on my own. Leads to a much more positive experience of interacting with it. OK. Till now, we've talked a lot about things that are useful when you are building software systems, during the ways to make code easier to work with during the development process. In the last part of the talk, I want to talk about what you can do to make systems that are easier when they are running. So it's finished. The system is in production. What we're going to be talking about now is monitoring and logging. So again, we're going to run two scenarios. First scenario, you come into work on a Monday morning, and the phone is ringing. And it's the bad phone. It's the external help desk number. And you pick it up, and you're like, good morning. And someone says, system's down. And you're like, OK, I've just got in. Let me take your number. I'll give you a call back in a few minutes when I've had a chance to check. And you hang up, and the phone rings again. You pick it up again. You're like, good morning. And someone says, yeah, system's down. And you're like, all right. And system's down. It doesn't work. The website's broken. The internet's off. Nothing's working. The SQL database is timed out or something. And eventually someone says, do you want me to send you a screenshot? And you say, yes, please. That would be lovely. And they send you this. And you get request timed out. And this doesn't give you anything to go on. Your boss comes over. It's like, the system's down. What are you doing? You're like, I'm trying to find a request timeout. How long is it going to take? I don't know. We got about 150,000 lines of code. I can probably check one every 2 minutes. You do the maths. I'll see you in 6 weeks. Boss is angry. You have no idea where to go from here. You've hit a dead end. People are shouting at you. People are shouting at each other. You're wanting to shout at people, but you can't because you're right at the bottom of the pecking order here. This is a really, really nasty way to try and diagnose a problem on a production system. This is bad. So what if you come in and you've thrown the phone away? Instead of the phone, there is a screen on the wall which has a monitoring dashboard that gives you a high-level view of your key systems. And most of the time, it looks like this, because most of the time, everything is green and everything works. You come in the morning, it looks like this. And before you've even taken your jacket off and put down your coffee, you're like, OK, well, that's the main web stack. That's the intranet. That's the content delivery network. And I'm pretty sure that if the CDN has gone down, this won't work and this won't work. So you immediately, you jump onto Slack, and you say to the rest of your team, looks like there's a problem on the main web stack. We're working on it. Update in 15 minutes. Great. people know that there's a problem. Anyone gets any calls, they're like, yeah, we're working on it. Meanwhile, you're like, okay, let's look at the content delivery network. That's probably the problem. Aha, the certificate has expired. Because how could we have possibly seen that coming? So, you know, you go through the renewal process, you get the new certificate on there, everything comes back up. Now, one of the kind of lovely side effects, a lot of the things I've discovered in the course of running these systems are things that you never plan for. By putting this up on a big screen on the wall where everyone has to, we put this in the corridor on the way to the main meeting room. So almost everyone in our company would walk past it at least a couple of times a week. And all of them start kind of picking up on it. And they're like, oh, everything's green. When it comes up and there's red on the board, you know, they'll just be like, you know, is everything okay? And then they'll offer to help. And it's brilliant. Instead of getting yelled at because the website doesn't work, people are like, oh, it looks like there's a problem. And they can see that you're busy. So one, they don't ask you for lottery money. And they don't ask you to sign Angie's leaving card. They're like, maybe now's a bad time. And sometimes I'd be like, you know, do you want me to, does anyone need coffee? I can go out and get some sandwiches. Do you need to order pizzas or something? And it's just a much, much nicer way of kind of everyone feeling like there's a problem. We're all on the same side. We all want to get the thing up and running. And even if you're not one of the engineers who can be working the incident, there's actually ways you can help with this just by being aware that that's what's going on right now. So this created this you know, sort of wonderful sense of everyone being on the same side just from putting it up on a wall where people could look at it. Now, this kind of, you know, systems monitoring, again, it's a bit like user interface design. If you put a warning light on every single moving part in your entire estate, you're going to end up with something that looks like this. And there's always things that are broken. And it's really, you're familiar with the thing called the broken windows theorem? This idea in, you know, like derelict neighborhoods, if you break a window on a building and no one fixes it, within a month all the other windows will have been broken because one broken window sends a signal that nobody cares. These kind of dashboard systems, you want a small enough number that most of the time they're green. You want to draw the abstraction at a sensible place. In any complex system, there's going to be something right now that isn't working. You're going to have one of your servers will have one disk that's got, like, it's down to less than 10% free disk space. One of your APIs is going to be running a little bit slow. One of your databases is running a transaction log backup right now, so things are taking longer than usual. So if you expose everything, there are always going to be pieces of it that don't work. This is the space shuttle flight deck. And there's a quote from someone about the shuttle that said, you know, the shuttle had 6 million moving parts with a 99.9% success rate, which means you're going to get 6,000 mechanical failures on every single mission you ever have. And they need to know about it. But we aren't trained to operate something like this. We don't know which lights to ignore. We want something like this. We want a kind of high level. The databases are good. The web stack is good. The CDN is good. The image server is good. The account system might be having a problem. Go and look over there. It's that kind of, you know, level of visibility that we want to create. Now, you can also, as well as monitoring your systems externally, you can achieve an enormous amount by exposing the internals to the people who need to look at them. I always loved, I grew up on Star Trek: The Next Generation. That was like my TV show when I was a teenager. And one of the things I loved about it is that all the engineering, the engine room of the Starship Enterprise wasn't hidden away somewhere. It's out on display where you can see it. And there's a couple of episodes where you tune in, and this thing in the middle, which I happen to know from my time in show business is actually a tank full of gin and tonic. If this thing wasn't glowing, you knew there was a problem. It's like, that's bad. The Starship Enterprise's engine is not working. This is going to be the plot for this week's episode. I wonder how they're going to fix it. And you can do the same kind of thing in the way we build software systems. There's a framework called Nancy. Anyone here used Nancy for building stuff? So Nancy is it's an alternative to ASP.NET. It's an open source framework for building websites and APIs in .NET. And one of the lovely things about Nancy is it comes with a built-in dashboard. So this is a live Nancy system. This is the backend to that API Explorer I showed you a moment ago. And all we've done here is we've added one line to the configuration file, which has created a lumberjack. There we go. So we've added one line to the config file, which enables this. So you got to underscore Nancy on that API. You put in your authentication password. And this is the equivalent of like taking the panels off your car while the engine is running. You can see inside the system while it's running. So this is live view on a production system. You can see every single piece of configuration. You can see the DLL versions, the deployment paths, all of the services that have been registered. And sometimes you'll notice that these are not the services you thought you'd registered, because there's an error in one of the config files, or there's a piece of configuration that's not being picked up. You can get it to dump all of the routes that have been configured using the runtime that's actually there on the server. So if you think you've configured something, you can go in here and go, well, did that do what I thought it was going to do? OK, look, there, it did. We've got put and delete support on this. And the really, really powerful thing is you can go into the config settings, and you can switch on something called request tracing. And request tracing will capture every single piece of traffic that hits that server and save all of the details so you can go in and look at them. So if you're having problems with requests from a particular client, this will show you every single, so you can see all the headers that have been added by Cloudflare, by Amazon's Elastic Load Balancer, by proxies, certificate discovery, all this kind of stuff. It's like the network inspector in Chrome, but from the other side, on a production system. And as soon as you've found the issue or fixed the issue, you just go back into request tracing, you switch it off. The impact is minimal. The footprint and the overhead are relatively minimal. It's a really, really nice way of giving you another view into what your system is actually doing, other than just hitting web pages in a browser and hoping that you get the right thing come back off the other end. So the last thing we are going to talk about is logging, because being able to get insight, yeah, that's what's with the lumberjacks. Up till now, everything we've looked at, it'll tell you what your system's doing right now. It'll show you, is it up, is it down, do we have a problem? What it won't do is tell you how it got there, and that can sometimes be the most important part of any diagnostic journey. So let's say we get into work one morning and there is a problem. The system is down, and we know that because the dashboard is red, and we do a bit of digging, and this is our main database server, the cluster that's running all of our systems, and the CPU consumption is at 100%. Now that's something, at least we have something to go on. Why is it at 100%? How did it get there? Because unless we understand that, we really have no idea what we are looking at with this one isolated data point. Now, one explanation is that it's done this. Something has just been climbing slowly, 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 and it's just hit the point where it's a problem. Or maybe this has happened. Some routine scheduled task, most of the time the database is absolutely fine, but some routine task has just suddenly gone bang and hit 100%. Or maybe it was absolutely fine all along until earlier this afternoon when you went, yep, I'm going to deploy this to production now, it looks good, and bang, suddenly you're at 100%. And even having that kind of history, that's only half the story. We have these three different scenarios. Now, if this time axis here is, say, 12 hours, 10 o'clock, 11 o'clock, 12 o'clock, each of those three lines tells you a very different story. This green one here, you're like, well, what do we do every hour? What's our database server doing? Are we backing up transaction logs? Is there some kind of computation job that's running? The blue one is like, what happened last night? Did we send out a massive marketing campaign maybe? And so this is just loads and loads of people opening their email and clicking through to get special offers on our website. The red one is, did I just deploy something to production that's accidentally broken everything? If that time axis is January, February, March, April, again, the shapes are the same, the curves are the same, the problem is the same, but they tell a very, very different story. The green line here is what do we do every month? It's not hourly anymore. It's like, what are we doing on the first Sunday of every month that has just started taking our database server out? Do we have some kind of end-of-month financial reporting? Is this some, Sarbanes-Oxley compliance routine we're having to run? This blue one is like, are we just having a really good year? Are we getting loads of customers and loads of orders and our database is growing? And we probably should have spotted about here and gone to the finance team and said, we're going to need budget for more infrastructure here. And they're like, why? And you say, we are going to run out of database capacity on July the 14th at 3:30 in the afternoon. And they'll be like, well, that sounds bad. Here, have some money. It's much better than going to them afterwards and going, we need money because we need a bigger database because ours has run out of space. This allows you to forecast, to actually have those kinds of conversations as business decisions and strategy instead of as operational firefighting. And the red line is probably still, at this point, you've gone 6 months without deploying anything broken to production, but, everyone makes mistakes. Oops. Roll it back, see what the problem was, start again. This is a real snapshot from a real tool. It's a Redgate product. It's called SQL Monitor. And this is actually 24 hours of real database metrics from our main, Spotlight's main production server. And the interesting thing, you see this kind of curve here. We got this thing here, bang, and then down again. That's nightly backups. That happens every night. We rattle along quietly overnight. Everyone comes to work in the morning because most of our customers are based in the UK. They all use the website all day to do their thing, and then at 6 p.m. everyone goes to the pub or goes to the theater, and everything drops right off again. And so just being familiar with this shape and the fact that this happens every day, when something weird happens, the first thing you do, you pull this up and you're like, does today look different? Is there something weird? You know? And sometimes you'll be like, what was going on at 4 o'clock in the morning? And then you realize that someone put out a massive job for, you know, like Game of Thrones, which they put out from Eastern Europe, so everyone had to get up early that day to try and get applications in. Sometimes there's a massive spike in the evening. You're like, what was that? Well, that was probably Star Wars, because that went out late in the day because it was sent out by an agency in LA. And it's really interesting being able to isolate those anomalies and go, well, this was a business thing and this was a business thing, but this one here was technical, so we probably better go and look at what's going on with that one. This kind of, you know, metrics, this will show you what's happening to your systems, what's happening on your networks, what's happening with your CPU and memory. To actually understand what was causing it, we need to know what the software was doing at the time the weird thing happened. And that's where we get onto the last part of the talk, which is about logging. Now, logging is one of those things that's very, very easy to do badly and very, very difficult to do well. One of the key things about any kind of logging in your applications is get the logs off the system that is running and get them into something centralized. Right across your whole infrastructure, get all of it onto a centralized logging platform. Maybe you can roll your own, maybe just put them in a database table. There's lots of software as a service platforms that do this. And what you'll find, particularly if you've got different systems that were either built at different times or different platforms or different teams, is no one agrees what these different levels mean. Because we have this consensus. We have fatal, error, warn, info, and debug. And this started out in Apache in the 1990s and has just kind of flowed through almost all logging frameworks, certainly that I've ever used. And in order to make a kind of, you know, sense of a centralized logging system, you need to agree what these things mean. Now, to me, fatal means this is a big deal, wake people up, something has gone seriously wrong. And in most companies, there will be a bunch of systems that are not important enough to throw a fatal exception. If you have a thing that your sales team used to send marketing emails, and it stops working at 2 o'clock in the morning on a Sunday, do you need to know about it? No. You know, that's something you can investigate on Monday when you get back to work or when somebody comes on shift. Those kinds of things, you don't need to wake people up because they don't matter, because no one's using them at the point where you detect the problem. And maybe it'll go away by itself. But there will be fatal errors. You know, the entire system's down. The database has just crashed. We've got corrupted backups. There are things that you want to know about immediately to give you the best head start to fix them before anybody notices. Errors and warnings, to me, this is how you log the inevitable things that happen because distributed computing is built out of abstractions that don't always work. Network timeouts, you know, something, transaction deadlocks, 2 database operations trying to write to the same table, and one of them just, you know, it will get killed. The database will just go, no, you failed. You try again later. This transaction won, you lost, off you go. To me, errors are things that somebody noticed. Like, you know, request timed out, all right, well, they probably pressed F5 and it worked the second time. You'll get a flutter of those, they'll happen. To me, warnings are things nobody noticed, but it's still a little bit odd. Maybe you have a system which gets foreign exchange rates, currency exchange rates from a remote API. If you get a timeout on that, that's all right. You have a cached one from 2 minutes ago. 2 minutes is fine, fall back. And times that again, 5 minutes, 10 minutes. If you're using exchange rates that are an hour out of date, for most businesses that's probably okay. If they're a day out of date, maybe that's a problem. If they're a month out of date, you could be seriously, you know, losing money. To me, the thing about these, the individual messages aren't useful. They're like volume. If you know, ride a bus or the metro and you see somebody dressed as Jack Sparrow or Mr. Stay Puft or something, that's normal. Any given day in a city like this, there's probably a couple of people going to a costume party. If you get on the metro and it looks like this is interesting. Because, you know, something is going on here. Something is weird. Errors and warnings are like people on the tube or the metro in fancy dress. If you see lots of them, that's a sign that something's going on. To me, info messages are reassurance. The main reason for info messages, let's say it's a bank holiday weekend, you all, you know, you go home on Friday, you're going to have some beers with your team, you go home for the weekend, you come in on Tuesday morning, you look in the logs, empty. Nothing there. Nothing logged at all for 72 hours. Now, maybe you had a perfect weekend. There were no errors, no warnings, no fatals, no timeouts, no exceptions, nothing. There is another explanation. Anyone want to hazard what it might be? The logging infrastructure fell over while you were in the pub on Friday and you haven't recorded anything. Info is just the heartbeat. You know, it's log sunning every 5 minutes. If you've got like a routine recycling and application cache, if you've got a database server that's flushing transaction logs to disk every 10 minutes or something, info those messages, just so when you go and look, you're like, actually, we did have a perfect weekend. Everything's been up, everything's been running, we've had no problems at all. This is brilliant, you know. And debug is, to me, well, debug is all the things. Debug is all the stuff that was useful to you. One of the best habits you can get into as a developer, I think, is when you're building a new system or a new application and you go for the, you know, what's going on here? Console.writeLine. Or, you know, you go to response.write something, or you start attaching debuggers. Think, no, let's log that. At that point, just stop, find, there's probably a logging framework already baked into it if you're using any kind of framework. If there's not, install one and start using, you know, log.debug for that kind of output. And yes, you are going to get a lot of stuff, because a lot of that information, when you're developing a system, you want really good visibility on all sorts of aspects of it. But then when you deploy to production, you can just tweak the config and you can switch that off. And it won't happen. It won't cause noise. It won't fill up your disks. It won't fill up your infrastructure. But the great benefit in that is that you will, at some point in your career, have a problem that doesn't happen locally. It doesn't happen on dev. It doesn't happen on staging. It doesn't happen during the day. It only happens in the middle of the night on a production system when VIP customers are using it. And at that point, you are really going to be glad that you can switch debug back on, and you can see everything that's going on that system just as if you were running it on your own machine. I actually think all of this confusion around logging is just because they picked dumb names when they came up with this thing originally. What they should have done is use nice verbose names that told you what they actually meant. So instead of log.fatal, we should have to write in code log.wakemeup at 4 a.m. on a Sunday. You don't write that unless you're serious. Log.error should be called apologize to the user and raise a ticket. Log.warn should be tell me if this happens 1,000 times. Log.info should be everything's fine, we're just checking in. And log.debug should be called log.fillmyc drive with stack traces. Because if you use it unwisely, this is what will happen. And these, by the way, there was a guy called Daniel Librero wrote a post which kind of had the origins of this idea, and I sort of took it and ran with it. So the credit for this slide goes to him. OK, so let's recap. Thank you, Projector, for staying with us all the way through part 4. The rules of happy code. Number 1, remember Applejack, the My Little Pony and the cowboy hat, and all the other ponies. Or any system you like, give things names. If you're building systems that communicate with one another, just come up with names for them. They don't have to be product names. They don't have to be marketing approved names. They don't need to be signed off. Just come up with code names. You know, My Little Ponies, capital cities, single malt scotch, anything you like. Just have a quick way of coming up with names. It'll seem stupid for a couple of days, and everyone will feel a little bit embarrassed that they're talking about Applejack and Bumblebee in a project design meeting. And after that, it'll be fine. And when new people join, they'll be like, why are you talking about ponies? And you'll be like, yeah, bounded context. You know, it's a good way. It's how we do it. And you're like, by the way, look, this is in the logs. This is our repositories. This is our wiki. This is our monitors. They'll be like, all right, I get it. I don't like it, but I get it. And after a couple of days, they'll not complain anymore, and it'll work. Learning curves. You know, remember the owl. Try and create systems that, if you want to work hard at them, they reward you. Look out for the localized peaks. Remember web forms. Try not to build abstractions which lead someone in completely the wrong direction, because they'll be happy until they realize what you've done, and at that point they will be unhappy and they will probably hate you. And they might be used 6 months down the line when you come back to your own system. When you're creating error messages, please do this and not this. You know what happened. At the point where your code needs to throw an exception someone else is going to pick up, you know lots and lots of context that that user is not going to have. Don't ever do the operation could not be completed unspecified error. You know, give us something to go on. I don't even, what was it you were trying to do? What was it that was unspecified? What operation could not be completed? If you can, if you keep, you know, when you're building something, you hit the same brick wall every time, think, what have I got here, you know, in my log files or in my notebook that I could actually put in the exception and just take the brick wall away, make it part of the journey? Signposting. Think about, you know, IntelliSense. Think about responsive user interfaces. Think about the portal tutorial. Think about using hypermedia and explorers, and create systems that people can, at any point, they can be like, all right, well, where can I go from here? What options are open to me from here? Transparency. Put screens on the wall. Expose dashboards. Build endpoints in your systems that just return information you can use for monitoring and logging them. Do everything you can to give everyone the best insight into the way your systems are actually working. And the golden rule of happy code is, remember, all of us are creating user experiences all the time. The one rule to rule them all. Whatever you're doing, if you're building a database, someone's going to be using your data. If you're building a class library, someone's going to be using your classes. building an API, someone is going to be using your API endpoints. And it's up to us whether that person is going to have a good day and go home with a smile on their face, or they're going to have a grumpy day and end up shipping something crappy. So let's try and make happy code. Thank you.